So today we'll be talking about hexagonal architecture in monoliths and microservices. Firstly, a short introduction about myself. So I'm a technical coach and I help development teams to introduce hexagonal architecture, clean architecture, and test-driven development. And the whole purpose of this is to help improve quality, accelerate delivery, and to build more easier to maintain software. I also write articles about these topics, so feel free to connect or follow me on social media. Now for the overview for today. So we will be looking at hexagonal architecture and its applications within its usage in monolithic backends and microservice backends. We will then zoom into test automation with hexagonal architecture. And finally, we will also have a short code demo to illustrate some of these concepts in practice. So starting off with hexagonal architecture, a foundational overview. The whole motivation behind hexagonal architecture is that we want to isolate our business logic, so the application representing the business logic, to isolate it away from UI or databases so that we can develop applications and test them in isolation from any of these I/O concerns. And this is typically really helpful in applications with higher business complexity. And this goes into the why behind hexagonal architecture. So hexagonal architecture helps us to decouple away business concerns from infrastructure concerns, and this helps solve the problem of software maintainability, which is a big challenge within software development. And the other useful part about hexagonal architecture is you can apply it irrespective of whether you're working with monoliths, modular monoliths, or microservices. This is a short diagram illustrating what hexagonal architecture looks like. So on the left-hand side, we have users who want to use our application, and we can also have external web services which may need to communicate with our application. And we can also have test scripts. So these are the primary actors. Now, to interact with our application, we make adapters suitable for the type of actor. So for example, for users, we may need to make a UI, and for web services, we may need to expose a REST API so that they can communicate with us. So these are the driving adapters within hexagonal architecture. Then we have the application core or the hexagon, and that contains the meat of the application. So containing all the business logic. We have driving ports on the left-hand side, and these expose use cases. So examples could be to place an order, to cancel an order, to approve an order. So those are the use cases which are at the boundary of the application, and adapters can call the use cases. Then on the right-hand side, we have the situation that sometimes our application may need to communicate with some I/O. For example, we may need to persist data to databases files, or we may need to communicate with some external web services. So instead of directly being coupled to those I/O concerns, we want to be decoupled from them. So we introduce these driven ports as interfaces to abstract away the external world, and then we have driven adapters which contain any of the mapping infrastructure code to help to connect to databases, work with databases files, and other external web services. And if you want to get a bigger foundation in some of these topics, feel free to have a look at some of my previous meetups. Now let's look at how Hexagonal architecture is useful in the case of monolithic backends. So this diagram illustrates users which are using a system, and this system contains a front end and a monolithic backend, and there is also communication with third-party systems. And in this case, the backend is a monolith. And here, this backend monolith, it could be implemented in any way you choose to. You could have a typical three-layer application, for example, having controllers, services, repositories, which is very common in, for example, typical Spring applications. Or you can have structure it as hexagonal architecture with having the driving adapters, driving ports, driven ports, and driven adapters, and the hexagon. In either case, you can use a Spring. And so this is just illustrating the architecture and the fact that what kind of tests would exist in the case of using hexagonal architecture. On one hand, we would have unit tests, which target the core for testing business logic, integration tests, which target integration with the external world, and component testing, which spans the whole, essentially, monolith in order to verify that, for example, that its connectiveness. Lastly, we also have end-to-end tests, which span everything. And this is essentially a pyramid representation of the previous slides, that for testing the backend, that we would have the unit test, integration tests, component tests. And as we can see here, the majority would be unit tests, so testing the hexagon. Next, let's look at hexagonal architecture within microservice backends. So we have the same architecture diagram as before, but the difference is that now the backend is no longer a monolith. Now it is a microservice backend. So typically here we have an API gateway. We could have multiple microservices, and these microservices may communicate with each other and with message brokers, and also with third-party systems. Here, again, each microservice could be structured in any way you want. Maybe for some microservices, you choose CRUD, typical CRUD architecture, or maybe you choose hexagonal architecture. Here, I've illustrated all of these with hexagonal architecture. And we have the same test types that we previously covered in the case of monoliths, but here the difference is that now all of these test types are applied at each microservice, because each microservice we can model as with hexagonal architecture. And we have the same pyramid as before, so indicating that majority of the microservice would be tested with unit tests to verify the microservice business logic, and some smaller part would be verified with using integration testing to verify its integration with the external world. And lastly, component testing the whole microservice in entirety. I do want to emphasize that in any of these test types that we are testing the microservice in isolation from any other microservices. And lastly, we also have end-to-end tests, which span the whole system and the external systems. Now let's drill down into test automation. How do we test with hexagonal architecture? And this is a really big motivating factor behind using hexagonal architecture, because hexagonal architecture really helps bring a higher level of testability for business logic, because we separate the application with its business logic, we separate it from the external world, and it gives us a big benefit regarding testability. Let's start off with the highest possible level of testing. So this is end-to-end testing, for example, using Cypress or Selenium, and it spans the whole system and external systems. So End-to-end tests might be targeting the front end or might be targeting the REST API exposed by the backend. And here the backend is a black box. It could be monolith, it could be microservices, it could be big inside, we could have big ball of mud, or we could have hexagonal architecture. It really doesn't matter at this level of testing. Next, we want to zoom into the backend, and let's look at the backend. How do we test the backend? And this is where component testing is useful. So with component testing, we can verify the behavior of backend, whether it's monolith or microservice, by testing essentially that monolith in isolation or testing the microservice, each microservice in isolation. In the case of monoliths, component test, it hits, for example, the REST API exposed by the monolith, and the third-party systems are mocked out. This is really important. This is what enables us to test the backend in isolation from external systems. And in the case of microservices, it is similar as backend, as the case of monoliths. The difference is that here we might be targeting either the REST API or message consumers. That's the typical entry points to the microservice. So that's what our tests target. And again, to make sure that each microservice is tested in isolation from the external world, we mock out both third-party systems and we also mock out other microservices. This means when you have your pipeline for testing, you can test this monolith backend or microservice backend in isolation from everything else. And this diagram indicates component testing in the case of hexagonal architecture being applied. So component tests, they target the driving adapters. So for example, driving adapters might be the REST API or message consumers. So that's what the tests target. And these tests, they span the whole monolith or microservice, so spanning all of this. The part where we reach the boundaries on the right-hand side when we get to these driven adapters. In the case of databases, we can use the real database. For example, you can use, with Java, test containers. So this means you can spin up a component test with the real database, which gives you higher realism because database is contained by the microservice. But for communication with other microservices or third-party systems, that's the case where we want to stub it out, not use the real one. And this is what enables us to have component testing like in isolation, to test the monolith or microservice in isolation. Now we want to zoom into some inside the hexagon into integration testing. So we will look at integration testing on the driving side, that's the left side, and later also on the right-hand side. So on the left side, we have driving adapters. They could be REST API, SOAP API, RabbitMQ consumer, Kafka consumer. All of those are entry points to the microservice. And let's look at integration tests which target those. So we write integration tests that target the REST API or message consumers, but here we mock out the application. These tests will not span the real business logic. What's the point of this? Well, the point is that these driving adapters like REST API may have some logic, for example, how they process the request before passing it to the application core, or they may have some logic, how do they take the response from the application core and how do they convert it to HTTP status code and body and stuff like that. All of that is possibility for bugs, and that's the purpose of these kind of tests, to identify essentially bugs within infrastructure logic. Let's look now on the right-hand side, integration testing for the driven side. So on the driven side, we could have driven adapters. For example, we could use HTTP clients to communicate with other third-party systems or other microservices. We could have database clients or ORMs for persistence. And we could also communicate with some message publisher for publishing messages to other microservices. Again, all of these could have possibilities for bugs, disintegration. Let's look at these types of tests. So here, these integration tests would be targeting the driven ports, so tests which are targeting these interfaces. Now, we know that each interface can have multiple implementations, so multiple driven adapters. The idea is for one driven port, you write a test file and then you can execute it against multiple driven adapters so that you can be sure that they all adhere essentially to the expected behavior. So what this is useful for, what kind of bugs this protects us against. You may have bugs, for example, that you're incorrectly calling some SQL statement, or maybe you haven't set up Hibernate properly in case of databases, or perhaps you're communicating with an external web service or another microservice, and you're not properly mapping your data to the data that they need, or anything like that. So essentially, again, identifying certain bugs in infrastructure logic. Lastly, so now that we've covered integration testing, let's look at unit testing. Unit tests are a big topic. Beyond the scope of this presentation, I would highly recommend looking at Martin Fowler's article about unit tests and understanding the difference between sociable unit tests and solitary unit tests, because there's a big controversy regarding unit tests. In this case, I'm going to show one of these variants, the first one, writing sociable unit tests for use cases, because that's the approach that I'm currently using and recommending. So we write unit tests, and these unit tests are targeting the driving ports, which are exposing the use cases. And essentially, we can see that these unit tests, they are spanning business logic. They're spanning this code within the application core. Now, on the right-hand side, we don't want unit tests to hit the database or to hit external systems or to hit other microservices. So here at this boundary, we use test doubles. So maybe you might be using fakes or mocks, stubs, etc. And then the whole purpose is that these unit tests, they could identify bugs in business logic. For example, maybe you have some incorrect calculation for the order price or something like that. Now that we had an overview of the different test types, let's look at a code demo. These are some GitHub projects which illustrate the usage of hexagonal architecture, and here I'm going to show the Java one. So I'm going to screen share now the code. I hope that you can see the code. So I will now show just a quick overview of the structure in the case of hexagonal architecture. So we have the driver ports, that's on the left-hand side. We have the driven ports, which are on the right-hand side. And we have the internal, that's the application core. The driver ports, they expose use cases. So for example, opening account, viewing an account, depositing funds into the account. The driven ports, they expose communication with any I/O concerns. So for example, might expose communication with some persistence mechanism, or communication with, let's say, here, some customer microservice. So we abstract them away as interfaces. And let's have a look, and then also we can implement the use cases, and we will now have a look at each of these. So we could have an open account request. So this is someone wants to open up a bank account, and when a bank account is opened, then we have the response. We could have some use case implementation. So given a request, we do some validation. We check, does that a national number exist? Is the customer blacklisted? And here we happen to be communicating with another microservice, the customer microservice, but we're not directly communicating it. We're communicating via an interface. We have some unit testing. Unit test for this use case file. This is where we use test doubles for any dependencies. And so here we're essentially verifying that we were able to open up a bank account. Now, notice previously I mentioned that this current banking microservice is communicating with the customer microservice, which is abstracted away by customer gateway. It's an interface. Now, when it's used within unit tests, this is where we need to use test doubles. Examples are fakes. So here I made a fake customer gateway, which simulates how the customer microservice works. But we also have the real implementation. So here we're communicating with via HTTP with the customer microservice, and we're interpreting its status codes and getting back the data that we want. And lastly, we also have tests for the customer gateway interface. And these tests can be essentially run against the implementation of the real customer gateway. And on the other side, since we're using packed contract testing, and that's again a whole big topic of its own, when we, for the team that's actually maintaining the customer gateway on their side, they would also be able to run contract tests on their side. So that was a short, very short overview of the code. I will now go back to resume as we're reaching the final slides. So to conclude, hexagonal architecture helps us develop and test our application in isolation from external technology concerns, in isolation from UI and database concerns. So in the case of Spring applications, it means that we want to be able to test business logic in isolation from REST API controllers and in isolation from Hibernate and any HTTP web clients, etc. We can use hexagonal architecture for both monolithic and microservice backends. In both of those cases, we can use it to decouple business logic, presentation logic, and infrastructure logic. And through this decoupling, we can use these different types of tests. So unit tests, which are concerned with business logic, integration tests to verify presentation logic, integration tests to verify infrastructure logic, and also component tests, which span a whole microservice in its entirety. The whole benefit of using hexagonal architecture and this test pyramid is higher testability, which results in lower maintenance costs and hence higher ROI. These are some reference materials about both hexagonal architecture and about microservices. I highly recommend the materials by Chris Richardson because he very nicely incorporates with Java examples both microservices and hexagonal architecture. I would like to say thank you for today. I hope that you found this session useful and maybe that you will look further into looking at hexagonal architecture. Feel free to connect with me or follow me on social media. So thanks for that. I'm now open to also any questions.